Good morning. This is our video for third grade for lesson 4.2. I'm Mr. Parks from Risen Christ Lutheran School. Today we're going to be working on the distributive property. We typically use this when we start getting into larger factors. So for instance, the one that we'll see on the screen, we are working with 6s and 8s. And so one of the things that we might do is go ahead and take a picture and break it apart into smaller groups. So for our problem here that we'll go over during class, we have Nell's neighborhood shows 6 rows with 8 blocks in each row. How many total blocks are there? Now, of course, when we have a picture like this, we could go ahead and count them up. However, that's not always going to be an option for us, especially when we get to state test questions. And they might have something that looks like this, but you're going to have a 6 on this side, and you're going to have an 8 on this side, and you're just going to have to kind of figure it out for yourself. You're not going to get squares that you can count. So one way that we might try to do that is to go ahead and take 1, 2, 3, 4, 5 of these guys and go across. And so we could do 5 times 8 for this part and 1 times 8 for the other part. And so if I do that, how many blocks are in the smaller array? We could get 8. And for our larger section there, we would have 40 squares, and we can skip count by 5. So that's one of the reasons why we use this, is so we can kind of start with something that's easier to work with that everybody can skip count by, and then we can work our way up from there. Why do you need to add the products? Well, if we don't add the products together, we're not going to get the total amount. So if I just take the 40 and stop there, or I take the 8 and stop there, I'm not going to get the complete answer. I'm going to need to add both of those together. Let's see. So for part C, it says 6 rows of 5 blocks and 6 rows of 3 blocks. So let's go ahead and change this real quick. And so we're going to take this and we're going to count over 1, 2, 3, 4, 5, and draw our line through like this so that you can see how that looks. So what equations could we write? We could do 6 times 5 equals 30. And then we could do 6 times 3 to get 18. And when we add those together, we would get 48. I'm usually going to recommend everyone try to find a group of 5. In this case, I think it's maybe a little bit easier to do 5 times 8 and then add the extra group of 8, because then we don't have to spend as much work to try to find the answer to 6 times 3. And then with the classmates, we would talk about how they broke apart their arrays, and then we could go from there, because we could do it in all sorts of different ways. We could break it up multiple times even. So our big vocab thing that we're working on for this lesson is a distributive property, which states that multiplying a sum by a number is the same as multiplying each addend by the number and then adding the products. So our example for 5 times 7, we're going to split that 7 apart into 3 plus 4. For this one, we would say that we would take our 8 and split it into 5 plus 3, for instance. We will eventually, as we do more practice, be able to do all of these steps, but this is kind of the introduction to that. So just be aware, you may see a homework problem that prepares the students for being able to do that in the future. Hope you have a great day, and I look forward to seeing you in the next video.